This is Garrett Fry, the instructor of the Color Workflow for VFX Artist course. To help you in your decision to take the course, I wanted to show you a quick sample from the slide presentation for this module that I think you'll enjoy. So here it is. In order to understand logarithmic data encoding, we need to understand how real light works. And it works in a linear manner. That means it goes from dark and it has equal steps between dark and light. To visualize linear light, we could graph it with a color curve. Down here is 0, that's absolute black, and we would be going up to 1, which is absolute white. And if you remember from a previous presentation, this graph represents normalized color values from 0 to 1. So real light is linear. However, human vision does not perceive light in a linear way. Earlier in the presentation, we talked about how the eye is made up of rods and cones. Along with a dilating iris, this gives humans the ability to have variable adaptive vision with greater sensitivity to dark values and less sensitivity to light values. So if you look at our linear curve here, you can see that the dark values and the light values take up the same amount of space, which doesn't really match the human eye very well, because in reality, there should be more space dedicated on this color curve to dark values than there would be to light values. So the question here is, should we capture image data that mimics real light, or should we capture it in a way that matches human perception of light? If we were to capture images linearly, then there would be a lot of wasted information on the curve up here at the top, because humans can't see that area anyways very well, and there would be not enough data down here at the bottom. So to compensate for the lack of information in the darks, your image capture would have to be huge, and ultimately, shooting in linear would be a waste of space. So if we were to rewrite this color curve in a way that would better simulate human vision, what would that look like? This is where the logarithmic color curve comes in. If you take a look at the space on this color curve that occupies the dark areas versus the light areas, you'll see that this part of the curve has a lot more information, and the lights have a lot less information, which better simulates how the eye perceives light. Logarithmic data encoding does not use a compression algorithm. In other words, it does not compress the image after it's been created, or decompress the image upon opening of the file. Rather, the data encoding is how the actual image data is written to the file, which means this logarithmic color curve is baked into the file as it's being captured from the camera. And just to give you a little bit of context, every digital cinema camera manufacturer has their own flavor of a logarithmic color curve used for recording. There's a lot more to discuss about logarithmic color curves that we will cover later in the data encoding slide presentation. But for now, you understand that data encoding is a perceptual data compression of the image. Thanks for watching this short excerpt from the slide presentation. To gain access to all of the training material, go ahead and enroll now.